Good evening again, class. We are looking at section 6.2, volumes, method of disk. This is being recorded again. And if any issue with privacy, you want to mute your video audio and change your name to initials. So in this section, we are looking at the method of volume, okay, the disk method to find the method of disk to find the volume of revolution. Basic integration formulas, as well as the previous section, the area of the region, okay, area of the region between two curves was discussed. And the main thing I want you to remember is dA is h dh, and you figure out what is the height and what is the h, and you are in good shape, okay, class? So it's important that you figure out what you need to do, okay. Again, I'm going to stop the video in case if you know it makes it a tad better. If it's blurry, please let me know. Anytime it becomes blurry, other than that, we are ready to move on. Okay, so we are looking at the disk method. Okay, so let me. So the area under the curve, we remember that. Okay. Now, if we take this and revolve it about some line, okay, it creates a disk. That line could be anything, the x-axis, the y-axis, or a specific line, okay, x equals this or x equals that, any. So take a look at what happens when we do that. So if you revolve this typical disk around the x-axis, this revolution creates this disk, okay? And this disk has the formula area is equal to pi r squared, right? Area is equal to pi r squared. What is the volume of this disk? This disk has a thickness. If it didn't have a thickness, it would have the area of pi r squared, and that's it. But since it has a thickness, the width of this strip, whatever it might be, W stands for the width, it's the X, then it generates the volume. So in essence, okay, it's a cylindrical shape, pi r squared h. We are looking at, class, this concept, okay? So this disk, pi r squared h. What is pi r squared? Is the area of the base, which is the disk. What is the height of that disk? In essence, okay, if we want to go with this one, so that means the thickness. So it creates the width, and it's giving us the volume. Now, if we add them all up, in other words, we make up more and more. Remember, this is a small strip, okay, a typical, okay, increment of a volume, which is the volume of this piece, pi r squared times dx. If we add them up, that means the Riemann sum, it becomes the total volume. And that means integration, class. So the cylinder V equals pi r squared h. Sometimes we use lowercase, sometimes uppercase. This is R, okay, class. R is the height, okay, or the y coordinate. Width is the dx. And we sum them up. This is the answer. And this equation is for horizontal axis of revolution. Okay, class? Okay, so in short, the volume of a disk is area of a slice times its thickness. So I'm going to go with pi r squared dh, which means I'm looking for the radius. And the radius is normally x or f of x. and dh is the thickness, which is either dx or dy. So this is the way I'm going to approach it. I think it makes it generalized and it makes it easier. And then we sum them up, and it gives us this, which is a Riemann sum, and in turn, it gives us the integral. R or h is the distance from the axis of rotation with, in this case, is dx. It could be dy, okay, class? So the distance from the axis of rotation is r or h. In this example, the width is dx. Therefore, rotation about the x-axis, if you look at what the text and many texts they do, they write for you is a of x dx. That means the area of this disk times dx. This is dv, believe it or not, if I write this in this form. This part is dv. And what I like to do, I like to call this pi r squared actually dh, because the reason I use dh, because you have to figure out it's dx or dy according to what you have. And so if we stick with that, just the way they have it, this becomes y, because class, this height is what? This point has coordinates x and y. It's the height is the y coordinate of this point. Look at this point, the y coordinate of this point. And the y coordinate is simply what? F of x or a of x, okay? So this equation is for a horizontal axis of revolution. A of x is the area of moving cross-section obtained by slicing through x perpendicular to the x-axis. So this is perpendicular to the x-axis, okay? What if it's rotation about the y-axis? What if we go this way? So look at this rotation. What about this rotation? In that case, we get a of y dy, which becomes pi r squared dy, which becomes x squared dy. Instead of that, I rather go with the way I write it. I'm going to write it class dv, and increment of a volume is pi r squared dh. Okay, what is r? You got to figure out it's normally either x or y. And what is dh? Well, if you go along the x-axis, we're going to go from a to b, right? Because we are revolving this way. To cover this, we have to go along the x-axis. It sweeps this along the x-axis, becomes dx. If it's the other way around, it's dy. So dh, you decide which one it is, and these are different ways of writing them. So to make some sense out of this, let's look at a simple example. Y equals square root of x. And suppose we start with this curve. How would we find the volume of this cone? Assuming this one, we want to find this one, the area for this, which looks like a cone, everybody. Okay. So let's see what happens. Let's go through the process. Let's cut it into thin slices, flat cylinders, and add their volumes. Please understand what happens here. If you revolve this way, typically this goes like that. And this is one piece. And then you have this following shape. Okay. And so having said that, this is R, which is Y, which is f of x. So again, this point class has coordinates x comma y, and R is the y coordinate of this function. The y coordinate of this function. So the volume of each flat cylinder is pi r squared. Okay, times what? The thickness of this class. What is this thickness? This thickness is dx. So this is pi, r is y. What is y? Square root of x. And the thickness is dx. Okay, class? So, an increment of the volume is pi y squared dx. And again, y is replaced by square root of x. We are going to do that from what? From 0 to 4, class. From 0 to 4. From 0 to 4. You square that, you get x. So the answer is pi over 2x squared from 0 to 4. You plug in 4, 0 has no effect. 4 gives you 16 divided by 2 is 8, so 8 pi. And that's the final answer. So let's quickly recap to see how this is done. You do the graph. Based on the graph, you come up with a vertical strip that you are going to revolve it, and then revolve it around either the x or y axis or any line that they tell us, okay? And then figure out what your R and thickness are. Practically, you're done. What do we mean by that? Well, let's find out. Let's look at this example. We want to find the volume of a solid of revolution generated by rotating about the x-axis, the region under the graph of this function. So we're going to graph this function, and it's bounded by these three, right? The function y equals 0, x equals 2, and here's what you have. Okay. Now, y equals 0, the x-axis, x equals 2 is a vertical line. So basically, you're looking at, do I want to shade it? Let's just quickly. We are looking at this shaded region, class. This is the region of interest, okay? And what is it that we want to do? Okay, we want to revolve this, okay, by the x-axis. So just to give you an idea, class, this is a typical strip. We want to revolve it this way, and that strip looks like this. And the whole thing, if you want to show the whole thing, it looks like this. Let me use a different color, actually. So it looks like this. And it's a typical strip. And so for this strip, okay, vertical strip, we want to create a volume. The volume that we want to create, class, is the area of this disk times its thickness. The thickness clearly is dx. And what is the area of this? Pi r squared. So the question is, what is r? I hope you realize that r is the y coordinate, if you will. So this is r, which is the y coordinate, or f of x. So class, this point has coordinates x and y, and r is the y coordinate of this point. So dv is pi y squared dx. This is an increment of a volume. If we can get this, the rest goes extremely fast, because we want to integrate the dv from a to b, and we're going to go from here to here, which means 0 to 2. By the way, you can put the pi in or out, makes no difference, class. Everybody can put it in or out, it doesn't matter. Okay, so y is x squared. That means this becomes x to the power of 4, and this becomes 1/5 x to the power of 5. Now, if you plug in 2 to the power of 5 is 32. So 32 pi over 5, 0 has no effect. gives you 0. So this is a simple calculation as long as we can figure out this one. So all you have to do, figure this out, class. So if you're looking at the method of disk, I would write dv is pi, okay, r squared. Don't write y squared, write r squared, okay, class, write r squared. R squared dh. dh becomes dx or dy. Or you have to figure out what r is. What about this one? Again, the function of y equals e to the power of x from -1 to 2. So let's quickly graph. Okay, from -1 to 2. This is what we want, right, class? So it's between that, and we want to revolve it about the x-axis. So the under that, between -1 and 2. Okay. So I hope you realize that this is a typical vertical strip we need. And if we do the revolving, looks like this, class. Okay. If we do the revolving, it looks like this. Okay. So let's go back here. dv is pi r squared dh. Pi r squared dh. So look at this vertical strip. When you revolve that, gives you this disk. Pi r squared dh. dh obviously is dx, and the r is the y coordinate. So this is what you need. R again is y or f of x. R is y or f of x. Okay, you can put this point here or this point here. Okay. And so you write down pi. We're going to replace the r with y, which is e to the power of x, and we're going to replace the dh with dx. Okay, which gives rise to the formula for the integration from, and this is obvious, from to. So from -1 to +2. Well, again, you put the pi in or out, it doesn't matter. As I said, you know, it doesn't matter. So this one is e to the power of 2x. And that means pi times e to the power of 2x divided by 2 from -1 to 2. Okay, so we are dividing by 2 outside or in, doesn't matter. Now you plug in 2, you get e to the power of 2 times 2, which is 4. If you plug in -1, e to the power of -2. So what I would do, the exact answer would look like this, class. Okay. Pi over 2, e to the power of 4, minus e to the power. You must write that, and it's an approximation. This approximation, I want to make a point. This approximation is not good, everybody. Why not? Because I'm just using what? Just 2 decimals, and that's really not acceptable. I want you to know that. I'm doing this on purpose. I want to make sure everybody follows what I'm saying. Don't do 2 decimals unless they ask you. This is exact. You can leave it like that. Okay? This is exact. All right. Now we have a situation where we want to do the same thing, but this time we're going to go along, around the y-axis. So we want to find the volume of a solid of revolution generated by rotating about what? The y-axis, and here's the situation: y equals x squared, x equals 0, y equals 4. So the very first thing, let's graph. So here's our graph, okay? So y equals x squared, x equals 0, okay, and y equals 4. This is x equals 0, y. In other words, if I were to shade the region class, okay, and so if I were to pick up a typical strip, would be like this, and when I revolve it about the y-axis, it gives me a disk, but along the y-axis. So what do we need? Okay, it looks like this. Okay, class. So the disk looks like that. Okay. Now we want pi r squared dh. What is this r? Okay, let's just actually write next to it. This one has coordinates what? X comma y. So what is this r? R equals x, everybody. R equals x. R equals x. And we are looking at this strip that we are going to go up and down, a vertical strip up and down, a horizontal strip up and down. That means this is dy, everybody. So pi r squared, we figured out that r is x. And so from here, what is x? Square root of y. And we figured out that dh must be dy. The thickness, everybody, is dy. So dv is a pi, okay, r squared when you square the r, that means x squared, that means y. This is r squared. So this, when you square it, you get to y. You can, if you want, you can change that. If it's easier, change this to r squared, okay? So pi okay, the r is x, so we x squared that, and then dy. So just plug in, and we are going to evaluate the integral from what? 0 to 4. 0 to 4. Again, I'm assuming everybody can do this class, so at this point, I wouldn't worry about that. So pi over 2 y squared from 0 to 4. If you plug in 4, you get 16 over 2 or 8 pi. Okay, I'm assuming we can do this in no time. Okay, I'm assuming we are okay with this. Here's another example that we are want to revolve about the y-axis. So x equals 1 over y, 1 over square root of y. Okay, and y between 1 and 4, and the y-axis, and it's revolved about the y-axis. So the very first thing is to figure out the graph. And here's the graph class. Just use you can even use a graphing utility to graph it. This is the graph of the function, and y is between 1 and 4. Okay. And the y-axis. So if I were to shade the region and the y-axis, so let me use, so this is the shaded region. Okay. And we want to revolve this about the y-axis. So this is the typical piece that we pick, a rectangular strip which is a horizontal one, and we go around the y axis. When we do that, this will create a disk, everybody. This disk, we need to know the following. Take a look. Pi r squared h, that means we need to know the radius r. I hope you realize the radius is the x coordinate, so the radius is x or f of y. And dh, the thickness is dy. So by the way, it creates a shape like that, horizontal disk, and the thickness of dy. So r or x or f of y or 1 over square root of y. This is x. So basically plug it into this. Okay, replace the r with 1 over square root of y. Okay, and square it. Replace the dh with h. So because the formula class is pi x squared dy, I can't emphasize enough, yx, this is the x coordinate. Let me just write it on this one. This one has coordinates x and y, and this distance is x. That's why x squared, and you're going to replace it with 1 over square root of y. The moment you see dy, you know that you have to change the x. And so 1 over square root of y, or simply 1 over y. This is the volume of a disk. And now that's a typical disk, and we are going to sum them up with the integration from 1 to 4. Now this is easy, 1 over 4, okay. 1 over, so pi remains, and 1 over y dy gives us natural log. Okay. So ln of 4 minus ln of 1 times pi, and ln of 1 goes to 0. So you're left with pi ln of 4. And that's what I mean. This is a precise answer, and you're done, and you want to keep it that way, everybody. Okay. Precise answer. All right. Let's look at something that is slightly different. It says the region bounded by y equals 2x, which is a line, and y equals x squared, and we want to revolve this about the y-axis. So we have the graphs, very straightforward class. So what we want is really this region and this region, only this region, and that's why we have a typical region here, where y equals x squared is the curve, y equals 2x is the line. Okay. So what happens when we deal with this? Take a look. This is a typical strip, and we are going to revolve this about the x-axis. So what happens is that this part, if I were to sort of, let me see if I can. So this part is the inner piece. This is the outer piece, and it's generating not a disk. It generates what we call a washer class. So take a look at that, take a look at that. This is the generation, and it is a washer. Take a look at the washer that it has generated. So the volume of a washer, okay, is pi times capital R squared minus pi lowercase r squared. This, I put that because of the text that uses. I don't want to use that. I want to use pi times r out. O stands for out. R out squared minus R in. So take a look at what is the R out. Take a look at the strip class. First, we are going to change y equals x squared to x equals square root of y, and y equals 2x to x equals y over 2. Because we are going to deal, obviously, the thickness is dy. Everybody can see the thickness is dy, so we need x as a function of y. So that's the first thing. The next thing I want you to notice is that R out is the x coordinate of the curve. So take a look. Take a look at this. I'm going to go back one more time. Take a look at this one. This is R out. R out, everybody, is from here to the outer piece of this one. Let me use a, see if I can use a color like this. Okay. From here, look at this point, everybody. This point. The outer part of the outer point of that green strip, okay, we have that. So from there to there, it's the x coordinate of the point on the graph of the curve. And here's the inner part. Look at the blue one. Here's the inner part. The x coordinate of the line, everybody, the x coordinate of the line is r in, the inner radius. So R out is the x coordinate for the curve, which is square root of y, and R in, this point, is the x coordinate of the line, which is y over 2. And so sticking with that, pi times R out, which is this one squared, minus R in, which is this one squared, times dh. We decided the thickness, we're going to go up and down, right? To cover this, that's dy. Outer, inner, thickness, but I'd rather go with my own method, R out and R in. I'm showing you both at the same time. I would stick with R out and R in. To me, it's a lot easier class. And so we are going to evaluate this from 0 to 4 because of the points of intersection. Okay, class? The y coordinate goes from 0 to 4. Now, the rest is simple. The hardest part is coming up with this class. If we come up with this, I can't imagine having any difficulty finishing it off. And that's the main part. So this is obviously y. This is y squared over 4. So y gives you 1/2 y squared, and this gives you 1/4 times 1/3. Okay, that means negative 1 over 12 y cubed. Okay. And of course, class, sometimes you see that one is missing. It shouldn't be. Okay. And you plug in 4 gives you an answer, 0 gives you 0, and there you have it. I'm assuming everybody can do this. All of this, okay, after this class. After this is one more step of calculus. The rest are just basic algebra. I'm assuming everybody can do that, so you don't want to spend any time on this. Okay. All right, let's go to the next example. Here's an interesting example. We want to prove the volume of a sphere when the radius is r is what we have seen, 4/3 pi r cubed. We want to prove that. Okay. So we're going to come up with a circle, place the sphere so that its center is at the origin, same as revolving a semicircle about the x-axis. So take a look at what happens. So the idea is that, class, you have a circle and the equation of a circle is what? X squared plus y squared equals r squared. Everybody knows that, right? If it's centered at 0, 0, x squared plus y squared equals r squared, okay? And so all we need is this top semicircle. So this top semicircle is the same thing, solve for y and keep the top piece, okay? Remember, y is plus minus the square root of r squared minus x squared. The top semicircle is just a plus 1. And we are going to revolve this about the x-axis. By the way, you can look at the right side and revolve it about the y-axis. It works out the same. So if this is the case, what we need to figure out is a typical vertical strip, okay? And then we are going to revolve it. So here's the strip and the distance from the axis of rotation. So let's just write this point as coordinates x and y, which come from the equation of y equals square root of r squared minus x squared, okay, the positive portion of this. So dv, let's go to dv. dv is a dh or pi r squared dh. So pi, we have it. R, okay, is what? R is this distance, the y distance as a function of x. And dh is this thickness, which is dx. So take a look. X squared plus y squared equals r squared. There are two answers. We just keep the top semicircle. dv is a times dh or pi r squared dh. We showed that the r is the y coordinate, everybody. And the y coordinate, we have the formula square root of r squared minus x squared. And dh, we said it's dx. Okay. So now let's evaluate the integral of dv, that means this piece, from a to b. So what is to be, class? From negative r to positive. So we're going to go all the way from negative r to r. Now this, you should be able to handle it. By the way, you can prove r squared minus x squared, this one, is an even function. I'm going to leave it for you to prove r squared minus x squared is an even function. So we can multiply by 2 and go from 0 to r to make life easier. So 2 pi is just a number, keep it. Why am I multiplying by 2? I'm changing this to 0. Can I do that? Yes. Prove show that f of minus x equals f of x. That's all you have to do. And so what happens? Now it's simple. 2 pi remains. Okay, 2 pi remains. R squared, okay, becomes r squared. X minus x squared becomes minus 1/3 x cubed. Just plug in. Of course, 0 gives you 0. Just plug in r. So this becomes r squared times r, which is r cubed. This becomes minus r cubed over 3. Okay. So it's 2r cubed over 3. Okay. Times 2 pi becomes 4 pi r cubed. I need to erase this, class. Sorry. So you can see this. Believe it or not, this is the proof. I highly recommend if you want to practice this, use the semicircle on the right, okay, and then revolve it about the y-axis. You will get to the same result. That would be a really nice practice if anybody is interested. Okay. I want to look at the last question. Okay. This is also an interesting question. It says determine the volume of a cone with a height of 50 cm, okay, and a circular base of 8 feet. So what we want to do, we want to use what we have just learned in this section to come up with this. Okay. So to do and a line, use some line actually about the x-axis, or you might decide to create a line about the y-axis. I'm going to leave it for you to try, see if you can figure that one out. Okay, that is also doable. Okay, and so here's the line. If you look at that class, has coordinates 15, 8. That means this is 15. This is 8. Okay. And this is a typical vertical strip if we revolve this about the x-axis. Gives us this disk. And when we revolve this, ultimately it creates a cone. So what do we need to figure out? Well, let's come up with the equation of a line. First, understand that if you revolve it, it looks like a cone class. It looks like a cone. And this is obviously, this thickness is your dx, and this distance is r. Okay. And this is the y. So if you're looking at this formula, pi r squared dh is obviously dx, and r is the y coordinate. Again, let's just actually write this point having coordinates x comma y. Okay, so the radius is actually the y coordinate. So the radius is the y coordinate, f of x equals 8 over 15x. So what we discuss is that y is 8 over 15x. I'm assuming you can figure out the following on your own. We have the following pairs. 0, 0 is one pair. 15, 8 is another pair. Convince yourself, given the two pairs, you can come up with the equation of this line, y equals 8 over 15x, okay? In fact, all you have to calculate the slope, y equals mx plus b, and b is 0. Okay, that I leave it for you. All you have to do, just finish the job as follows. So pi, and then r squared, we decided r is the y coordinate, so y squared times dh, we decided is dx, and we replace the y or f of x with 8 over 15x. Okay. So let me just write this, by the way, just in case. So dv is this, everybody. Okay, dv is pi y squared dx. And so this is pi. You square it, it becomes 64. You square the 15 becomes 225. I honestly believe from here on, it's just basic. You can do that. So pi times 64 over 225 and times x squared gives you 1/3 x cubed. 1/3 x cubed. 1/3 x cubed. So the numerator is 64 pi. The denominator is 225 times 3, which is 75 x cubed. From 0 to 15, all you have to do, plug in 15. It gives you 0 class. And it ends up being 320 pi cubic feet. What I want to add is this. Okay, we used calculus to prove this. At the same time, we remember the formula of a cone. The formula for the volume of a cone was what? 1/3 pi r squared h. 1/3 pi r squared h. So when you look at this cone, okay, what is the radius? 8. What is the height? 15. So 1/3 pi, 8 times 15, exactly the same answer. We know this formula, but the question is how to arrive at it. This shows this formula works, believe it or not.